Hi everyone, today we are going to solve 21st question on AMC 12A 2012. Let A, B, and C be positive integers with this inequality such that this equation and this equation exists. It asks for the value of A. So the first thing that I would do in this equation systems, is adding first equation to a second equation. So this gives me 14 equals to 2a squared, 2b squared, 2c squared minus 2ab minus 2ac and minus 2bc. Okay. I will do a nice grouping here. We are going to write this as this. Simply b minus c squared. This is a minus c squared. And this is a minus b squared. And this is 16. So it is obvious that those are integers. So the results should be perfect squares, which can be 0, 1, 4, 9. I don't go beyond 14, like writing 16. So I'm only going to work with 0, 1, 4, and 9. So it is obvious that those will be, the combination should be 1, 4, and 9. But here I also want to state something. Maybe you wanted to make sure that there is not an other combination other than this. So how we can show this, I don't know if it's a really accurate way of showing, but here is how I did it in the exam. So I said if I didn't get 9, the maximum thing that I could potentially get would be 12, which is less than 14. So I have to put a 9 here. So I have to get 5. I think for 4 and then concluded that the maximum result that I could possibly get would be 2, which would be below 5. So I also have to take 4, and then the final one is obvious, it's 1. So this is a simple way of showing that there does not exist any other combination. But here is another thing, how the sequence would be. So we know that the greatest difference between those numbers will be the difference between A and C. So I would go and write 9 to A minus C squared. But here is also an important catch. A minus B squared can be 1, but also it can be 4. So I'm going to work with those two systems. In one of the systems, there won't be an integer solution. In the other one of the systems, there will be an integer solution, which will be the answer. So I know that A must be C plus 3. You could write C as A minus 3, but usually I don't like dealing with negative numbers. So I'm just going to go and write C plus 3 instead of A. Okay. So here, let's start with the first one, which says that the difference between A and B should be 1. So I'm going to go and write C plus 3, C plus 2, and C. B equals C plus 2. And I'm right now going to plug those into this first equation. If you like, you can plug those into the third equation, but I don't want because there are some coefficients that would make it harder to calculate. I get the square of C plus 3, which is C squared 6C plus 9 minus C squared 4C and 4 minus C squared and plus C squared plus 5C plus 6 is 2011. So those cancel out. This is basically 7C. Yeah, 7C plus 11 equals 1211. So this basically says that 7C equals 2000, which cannot be true because C is an integer, and in this case, I know that 2000 isn't divisible by 7. So I have learned that this isn't the case. I'm going to go with this case, which the difference between A and B will be 2. So B should be C plus 3 is A. The difference will be 2, so B will be C plus 1, and C is C. I'm going to go with a new color and erase here. I take the square of a, which is c squared plus 9 plus c squared minus c squared minus 1 minus 2c minus c squared plus 8c plus 11 equals 2011, which basically is c equals 250. Don't go and pick B because the question asks A, and I know that A is definitely c plus 3. There's no other way for A, so I add 3 to this and I pick E as the right answer.